Good day everyone, you are welcome to GeoGGI Solution Tutorial channel. In this video, I want to show you how to do lineament mapping for groundwater potential analysis. In the previous video, I've shown you how to extract lineaments from digital elevation model. You can watch the video in the description box. However, in this current video, we want to show you how to do lineament mapping and reclassification for groundwater potential analysis. So before we start, let's quickly look at what is lineament density. A lineament refers to an extended line or curvilinear features mappable of surface whose parts are lying in straight or nearly straight relationship that can be product of faults, fractures or other tectonic activities in the subsurface. So lineament density maps display the distribution of lineaments in two-dimensional maps, and lineaments are of great hydrological importance as they are mainly associated with secondary porosity, permeability, and weather zone. So in this video, I'll show you how to do the lineament density mapping. In ArcGIS, I have these lineaments and the boundary of my study area. Now, if I want to do the lineament density of these lineaments, let me show you how to get it done. The first thing to do is to check the coordinate reference system of the lineaments. To do that, right-click the lineament layer and click on Properties. When it opens, come under Source and scroll down a bit and you can see the coordinate reference system of the lineaments. For instance, the coordinate reference system of this lineament is projected coordinate system, and if your own is in geographic coordinate system, you will need to project it because you can only run successfully the lineament density operations when the lineament is in projected coordinate reference system. So put it at the back of your mind. If it is geographic, then project it. So after you have confirmed the coordinate reference system of the lineaments, then let's start the lineament density mapping proper. So to do the lineament density mapping, come to Arc Toolbox and come to Spatial Analysis tool. Then come to Density, and here you can see line density. So double click to open the tool. When it opens, our input polyline feature, select the lineaments. Then our output raster, just navigate to your working folder. Let me call it lineament density. Click on Save. Come to Environment to set the environment. Come to Processing Extent, and the extent is going to be the extent of our study area, in this case Adamawa catchment. Then scroll down and come to Raster Analysis. Scroll down a bit and come to Mask. So the boundary we want to use to mask is our study area. So after you have set the environment, click on OK. And finally, we are ready to run the lineament density. Then click on OK. So this will run and create the lineament density in this study area. Yes, the lineament density is done. You can see the lineament density map. Let me uncheck the lineaments. Here is the lineament density, and in this case it ranges between 0 to 3.5. Now, how do we interpret or reclassify this for groundwater potential analysis? In this table 3.2, I have this criteria evaluation for groundwater potential, and here I have some criteria. One of it is lineament density. According to this table, the criteria named lineament density, it is said in this table that lineament density that ranges between 0 to 1 kilometer per square kilometer indicates low potential, and lineament density that range between 1 to 2 is moderate potential, why the lineament density greater than 2 is considered to be high potential according to these references. So on this basis, we are going to classify or reclassify the lineament density map we got into various potential zones. So to do that, let's go back to ArcGIS. Here is our lineament density map. So based on the value we get and based on the criteria evaluation for groundwater potential, we are going to reclassify this. This is actually in kilometer. So to do that, come back under spatial analysis tool, come to reclass, come to reclassify, double click it and it will open this reclassify tool. Then our input raster this time around will be our lineament density. Then the reclass field will be value, and then click on classify. Then based on our criteria evaluation I just shown you, we are going to have 3 classes, which is low potential, moderate potential and high potential, with this range accordingly. So in that case, we are going to have 3 classes here. So here we are going to set it manually. So let's go back and see the ranges: 0 to 1, 1 to 2 and greater than 2. So in that case, here will be 1 and here will be 2, and the last range or class will be greater than 2 kilometer per square kilometer. So click on OK. Here we can see that from 0 to 1 kilometer will be assigned a name value 1, and from 1 to 2 will be 2, and then greater than 2 kilometer will be 3. Then come here, navigate to your working folder. So let's just save it here as lineament potential. Then click on save and then click on OK. So this will run and reclassify our lineament density into 3 zones as reclassified. Yes, here is it. Let me uncheck this. Here in our study area, we can see that we have 3 classes of lineament density potential for groundwater occurrence. So what we can do is to give the appropriate classes they all belongs to. So to do that, right click and open the attributes table. We want to attribute the classes for each of the zones and also calculate area coverage. So to do that, we are going to add 2 more fields. Come to table option, then click on add field. Let's call this class, and then the type is going to be text, and let's make the length, let's say 30, and click on OK. You can see the field has been added. So the second field we are going to add is area. Come to table option and click on add field. Then let's name it area, and the type is going to be double, and then click on OK. So you can see now to attribute it, we are going to put the lineament density potential for groundwater occurrence into editing mode. So just right click and come to edit feature, click on start editing. Then here is our low potential. Here is moderate potential, and the final one is high potential. So to calculate the area, let's come to this lineament and check the cell size. So right click and click on properties, then come under source. Here is the cell size, so I can just right click and copy it. Then let's close this page. So to calculate the area, I'm going to calculate it in square kilometer. So to do that, I'll right click here and click on field calculator. Then the area will be equal to, let me open brackets, equal to count that is cell count, multiplied by the cell size I copy. So I'll just right click and paste it, times the cell size again, then close the brackets, and then divided by 1 million. So the area in square kilometer is equal to cell count multiplied by cell size multiplied by cell size, all divided by 1 million. So click on OK. Yes, this is area coverage of each class of lineament density potential for groundwater occurrence in the study area. For the low potential lineament density in the area, we can see the area. And for moderate potential of lineament density in the study area, we can see the area in square kilometer. And also for the high potential lineament density, we can see the area as well. So we can now close this, and then we have to style our map. To do that, right click and come to properties, then come to symbology, and then come here and select the value field. Click here and select class, and then we can click on OK. So you can see it here. Let me uncheck this. So you can see our lineament density potential for groundwater occurrence. So what I can do, I can take my map to layouts and add map elements. So to do that, let me close this page and then zoom to layer. Then come to layouts, and then let me just select a template. Click here and select portrait. Click on finish. Yes, I can just edit the map element. So add all your map elements and export it. So in essence, this is how to do lineament density mapping for groundwater potential analysis. If you have any question or clarification, let's know in the comment section. Thank you for watching.